The lesson topic for this video is solving polynomial equations using a graphing calculator. Alright, so we've done a lot of work already with this year. We can use a graphing calculator to find x when we know what y is. We can also use it to find y when we know what x is. That's just using trace. But the first thing I want to point out is if you just take a look at these three graphs in front of you, these are all examples of polynomial equations that have been graphed. Now, polynomials also includes, for example, quadratic equations, and we all know that a quadratic equation ends up being graphed as a parabola. So just a simple U-shaped curve. Okay, that's kind of messy, sorry. Now, with polynomials with a higher degree, so an x to the third power, an x to the fourth, x to the fifth, our graphs are going to have a lot more curve to them than just a u. So if you look at this first one, this graph is going infinitely down here, and it's coming up, it's peaking, it's coming back down, it's coming to a minimum here, it's going back up here somewhere, and back down. This graph is coming down here, back up, back down, bounces here, comes back up, etc. This one does something interesting. It's coming down. You can't see the whole screen. You have to just kind of visualize how it's coming down. And now it just kind of skims the surface here a little bit, and then it keeps going up as well. So these are some of the types that we'll be seeing during this unit. Now it says below here, for each graph, find x when y equals 0. Now let's remember that where y is 0 is on the x-axis. Okay, that's where y is equal to 0, right here, right? Because when y is 1, we're up here. When y is 2, up here. 3, 4, 5, maybe up to 10 or negative. Okay, so when y is 0, we're on the x-axis. Same thing on this one, and same thing on this one. Okay, so there's our y equals 0 line. So for each graph, find x when y equals 0 means that we're going to have several solutions. Okay, can you see that? All right, we're going to have a solution right here. We're going to have a solution right here. We're going to have a solution right here and a solution right here. Because the x value when y equals 0 depends on which location that you're talking about where y is 0, because it's hitting that axis several places. So on this one, for example, our solutions are probably what is the value of x. I've kind of covered over my graph quite a bit here, but we probably have 1, 2, 3, 4 to the left, so negative 4 right here would be my guess, negative 4. And then we've got right here at like about negative 1. Okay, I should write x equals negative 4. Let me do a little erasing here. X equals negative 4, x equals negative 1, x equals, we look right here, about 2, and x equals, let's see, 1, 2, 3, 4, 5, 6, 7, looks like 7, and x equals 7. So when y is 0, x is negative 4, negative 1, 2, and 7. Okay, for this next example, well, we see again one right here where y equals 0, so about negative 3. X equals negative 3. And another one right about here, so x equals negative 1. Oh, sorry, did I say positive 3? That should be negative 3. X equals negative 1. And then we have another one over here, and that's where x is 2. Okay, and now on this last one over here, we've got a location on x where y equals 0 here. The scale's a little bit bigger. I zoomed in. We got 1, 2, 3, 4, 5 to the left, so negative 5. And then we've got another one over here, right about there, and that's at x equals 2. So notice that the first graph, when y is 0, there were 4 solutions. On the second graph, when y is 0, there are 3 solutions. And on the third graph, when y equals 0, there were two solutions. So a lot of different things can happen depending on the shape of your curve. Okay, so how do we find the solutions to an equation using our graphing calculator? Well, we use the same steps as we have in linear equations and quadratic equations, so it's really nothing new. The first thing we do is we put our equation, let's use this example right here, which is a 4th degree polynomial, we put that into y1, okay? So make sure you use the caret, it's a little up arrow on your keypad when you're trying to raise to the 4th power. Now this is the screenshots of some TI calculators, but remember that the Casio calculator is the same process. So we have x to the 4th minus x to the 3rd minus 18x squared plus 52x minus 40. You type that in carefully. And our first example says find x when y equals 0. So of course we put 0 in for our y2 equation. And then of course we graph it. Now after we graph it, you'll notice, go ahead and try that on your calculator, pause, and then come back. When you graph it, you're going to see this type of graph here. So the function is coming down somewhere along the lines here, and then it's coming back up, and notice it's kind of straightening up here a little bit, and then it continues. And then what do we do to find the value of x? Well, we use intersection. And again, you guys have done this many times. So on the TI, you're going to hit second calculate, which is the trace button, and you're going to use 5 for the intersection. Remember, TI folks, you need to hit enter, enter, enter to find your first solution. And I say first solution, I'll talk about the second one in a second. So once you hit enter, 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 you're going to get a cursor and a intersection like this. So x equals 2.000078 when y is 0, which is what we were looking for. So x equals 2, okay? But remember that once you find x equals 2, you are not done solving, okay? X equals 2 is not the only solution. There is another solution over here. So TI folks, again, you need to hit second calculate, and then you need to use your arrow keys, your left or right arrow keys, to bring this cursor all the way down and around back up to somewhere near here before you hit enter, enter, enter again to get this location. Okay, so make sure you do that to find your second solution. It looks to me like it's at -5, but I will check on my calculator to see if it is exactly -5. 1 second. And it is at -5, so x equals -5. Those are our two solutions. There are only two solutions because there are two locations where the function goes through y equals 0. Now, the second example I have on the screen is to find x when y is -3. So again, the function's still in there, and now we're going to write y2 equals -3. So this graph right here shows us what's going on. We've got the function still here, and now we've got a line at y equals -3. There are still two solutions. You can see where the line crosses the function, and we do need to find both of those solutions. So same process, second calculate, intersect is 5, enter, enter, enter for TI people. Now, Casio, students with Casio calculators, yours is actually just slightly easier. Remember, you're going to hit F5, and then intersect is again F5 again. So you're hitting F5, F5, and you're going to find the first solution, and then all you need to do is use your left or right arrow keys to kind of just jump over to the other solution or solutions depending on the example. So here we've got x equals -4.991, and we need to find the other solution as well. And if you go ahead and jump over to the other solution or find the other solution, when y equals -3, it is x equals 1.216. So 1 and 216 thousandths. Okay, so just jumping back really quickly to our first screen we were looking at. So just notice that if you are asked to find x when y equals, in this example, 0 or whatever value it is, remember you just have to make sure you find every single one of the possible solutions. Casio people just by moving over left or right to each intersection, and TI people by running through that same second calculate intersection, enter, enter, enter at each of the locations.